All right, let's take the derivative of these. I made a mistake the first time. Let's not make that mistake this time. So, what are we going to do? All this example is really trying to show is that if you got a whole bunch of functions added together, you just take the derivative of each of them separately, which we should have already known because we've already learned that. But here we're just showing that it works for power rule as well. So, power rule, x cubed. Bring the power to the front. So bring the 3 to the front and decrease the power by 1. Make it x squared. Negative 4x, that's x to the first. So you move the 1 to the front. 1 times 4 is still negative 4. And then x to the first, well, you decrease it by 1. Now it's x to the 0. So we'll go ahead and write that out. 1 minus 1. But then, yeah, let's make it better now. So what is 1 minus 1? Well, it's 0. So we end up with x to the 0. So 4x to the 0, 3x squared. But then, yeah, x to the 0, which you see in the comments was my problem, is 1. So this should just be 3x squared minus 4 times 1, so just 4. And really, like this, that's something that you should get just in the hang of very quickly, is that if it's just x to the 1 here, the x just goes away when you take the derivative. So see, like we have the exact same scenario here with our negative 2x. So when we take the derivative, that's just going to turn into a negative 2. And then we do the derivative with everything else. Let's erase that because that looks like a fraction. So we take the derivative of negative 2x. We just get negative 2. We take the derivative of negative x to the fourth over 2. Well, the 4 moves to the front. Power decreases by 1. But the negative and the over 2 stay. And then the next power rule, bring the 3 to the front. 3 times 3 is 9. So 9x, decrease the power by 1, x squared. And then lastly, you just got to cancel. So negative 4 over 2 is negative 2. X cubed plus 9x squared minus 2. And that is our derivative.